Okay, guys, so welcome to another session, guys. I hope I'm audible loud and clear and you guys can see my screen. So, yesterday we could not meet. Somehow I got caught up in a meeting. Okay, sometimes it happens once in a week. Okay, where I don't have control. Okay, mostly we will meet on time, 9 o'clock. Okay, that's how it is going to be. Okay, so as per the course that we have discussed, right? Uh, we in the last demo we went over all the topics that we're going to cover in this course. That's going to be like divided into sections of cloud, right? As we discussed, going to be AWS cloud, exhaustive list of services, and it's going to be hands-on from scratch, as I told, right? Then it will be followed by the Linux. So Linux, as most of us, what I have observed, that we are comfortable with Windows, but not with Linux. As we are with Windows, as we are comfortable with Windows, we are not as that comfortable with Linux. So we're going to talk about that. The Linux scripting and Linux commands knowledge is very important. Okay, and that is indispensable. Okay, it's very important. So we're going to take care of that, right? After that, we will talk about the SRE. What is SRE? Why? What different terms that we have? We have high availability, fault tolerance, reliability, right? What is SLIs, SLOs, SLAs, error budgets, right? We'll talk about this incident management, why it is important, right? So these aspects of SRE we'll talk about. We'll talk about the architectures, right? The monolithic application, the microservices, where should we deploy the microservices? In what basis we deploy? We should create the microservices. We deploy on the containers. How do we create containers using Docker, right? And when we have a lot of containers, how do we orchestrate them using Kubernetes, right? So, and that's how it's going to be planned. And it's all going to be in the DevOps world. So what is the role of performance engineering in DevOps, right? How it fits in continuous performance testing in DevOps. How do we integrate CI/CD pipeline, create and integrate our performance testing into that? So all these things we're going to talk about it, right? Resilience and reliability in AWS. So we'll be mostly working on AWS, but I'll be also showing you GCP, Azure as well. Okay, so that you feel comfortable if you are not, if you're working in an organization where you are working not with AWS, but you should not feel like why AWS, right? So it's, if you know one cloud service provider, it doesn't matter. It's all about you knowing or getting comfortable used to the screen that Azure or GCP provides, right? The use cases remain the same. The use cases of the cloud service provider remain the same. Servers, storage, right? The IAM, the user permissions. Right? So the load balancer, the use case remain the same. Only thing you should know how to use it, right? The UI part of it, or if you're using command line, how to use that. That's what is the differentiating factor across multiple cloud service providers. We'll talk about observability in detail. We'll talk about Linux monitoring. We'll talk about CloudWatch, one of the out-of-the-box monitoring solution in AWS. Use CloudWatch, ELK, Prometheus Grafana. We'll use using Helm, right? We will be installing Prometheus Grafana in Kubernetes, right? Using Helm installation. That's one of the latest way of doing things in Kubernetes. We use Helm, right? Apart from that, you'll be getting access to the Java performance engineering recorded session. We'll be talking about Terraform and Ansible using automation. So the idea here, what I'm trying to focus, we are targeting 360 here. What all things, because SRE is a big domain, and we are trying to cater to all the requirements or all the requirements in the job description that you get as part of SRE from a troubleshooting point of view. We are not going to be as a support engineer, but if you're a junior, folks, you can try get your few first initial job as a support engineer. But if you're a senior into performance testing engineering already, so we would be trying to focus on the troubleshooting SRE part, where you would be working on the production reliability, the development part. How do you architect a solution? How do you make sure the application is reliable? Disaster recovery, we'll talk about that. So that's what we'll be focused on here, right? So this is about the course, guys. You'll be getting to get the Java programming language as well as the Python, right? Which is very much important nowadays. Automation, with chat GPT, your automation is becoming simple nowadays. Everyone would be expected to do automation at some level, and you guys should know these things. So it's a bundled course that we are offering as part of SRE and Cloud P, right? So we'll start with the first session today. Okay. Any question if you have, please feel free to ask any question, anyone. Okay. We'll take up the questions now, and if you're good, we'll start with the course syllabus. That's the cloud part. We'll talk about what is cloud, on-premise, what is cloud, what are the different service models in cloud. We'll talk about that. Let me know if you have any questions, any concerns here as part of this course. Okay. Silence means we're all good. Perfect. Makes sense. Okay. So we're going to get started. Okay. So this is the cloud console. Okay. But having said this, I'll explain about this cloud console. Okay. But before that, right, it's very important to understand what is cloud, right? Why are we learning cloud? That's what we need to understand first. So, anyone would like to help me with the definition of, let's say, let me put this. Okay, I'll bring a notepad. Okay, here. So we will talk about on-premise. So first of all, we need to know, before knowing cloud or defining cloud or the importance of cloud, somebody should know what is on-premise mean. What do we mean by on-premise system? Right? That's important. That's important. You cannot just overlook the importance of on-premise. We need to understand on-premise. Okay. Anybody would like to give their thought? What is on-premise? Okay. And what is cloud difference? In the very simplest term. Anybody would like to go ahead? Feel free. I'll chime in after that. Anybody? Feel free, guys.
Roshan,
Yeah.
So on-prem is about like we are owning the infrastructure, and in case of cloud, we are not owning the infrastructure. We are paying as we go. In on-prem, like environment is completely in our control. But in case of cloud, yes, like there are service provider like Google, Amazon, and definitely Microsoft.
Right.
For Azure.
You are there. Absolutely, you are there. I'll give you a better perspective. Almost you answered that, Paramveer. Yes, you answered that. I'll give you a different perspective. Okay. Before I talk about on-premise or cloud, let me talk about data center. How a data center looks like. Okay. See, either you are on-premise or cloud, the data center remains the same. Everyone. Okay. If I talk about data center, okay, this is how a data center looks like. So consider an outskirt of the city. Okay. Consider an outskirt of the city somewhere. An infrastructure multi-story building in the outskirts of city, and all the rooms, big halls, full of these servers. Right. So consider like this. I want you to imagine. Let me bring my slide. Okay. I'm gonna me. Okay. So now let's understand this. Okay. So this is how I usually start. I have just a slide for reference. I'm going to share all these things with you. Okay. So this is what a data center looks like. Consider. I would request you to be on mute. My voice is echoing. So if you could be on mute, thank you. So consider an outskirt of the city. Okay, like this, and a facility, infrastructure in the outskirt of the city, multi-story building, and all the rooms full of servers. Just imagine an infrastructure like this. Just imagine the think of, just try to imagine the money, right? The monetary aspect of it, how much it has been invested. So somebody, let's talk about that. Somebody has to procure the land first, multiple acres of land, looking at the facility, multiple acres of land in the vicinity outskirts of the city. So somebody has to travel always on daily basis in the outskirts of the city to maintain it. You have to purchase all the hardware, the servers that we talk about, the compute, the disk, right? Whatever we talk about, we have to purchase it. You have to purchase on in. That's how a data center is built. These servers which generate tremendous amount of heat, so you need to set up a lot of things about the cooling mechanism, because you cannot just keep. You have to check the temperature in control. So cooling has to be done for this infrastructure. These servers cannot lose the power, so you need to have multiple power sources for these servers to keep up and running. There will be servers which will be going out of service or not working, so you have to do operational cost also. You have to maintain the cost of it, right? Somebody has to inspect. There has to be monitoring for the servers, which server is operational, which is not. Somebody has to come and replace the rack, right? Lot of things, lot of maintenance, right? Multiple of everything. Internet service provider, multiple power switches, multiple, because the servers cannot lose the power. Internet connectivity 24/7. So that's how a data center is built. So I'll come to on-premise and cloud with the simplest definition. When you own this data center, when you have invested your own amount of your own money, when you own it, that becomes on-premise. As simple. When you don't own it, when someone else owns it, like AWS, Azure, or GCP, they have Microsoft, Google, they have set up these data centers all across the globe. When someone else owns it, and you go and ask for some servers, boss, can I use few servers? Can I use some storage? I'll pay some amount to you monthly. I'll pay rent, but can I use it as a rent basis? That is cloud. So technically, there is no difference. At the end, it's data center, and that's how it is. Either you set up or somebody else will set up. That's how it is. If you own, that becomes on-premise, or when you work for a company that the company owns it, that's on-premise, they call it. That's on-premise. But if someone else owns it, like AWS, Amazon, AWS, Microsoft Azure, or there are so many, Oracle, and you ask for the rent, when you want to use the servers, leverage some servers, storage services, you won't ask for it. That is cloud. That's how it is. And you pay as you go, as Paramveer rightly said. You will have to pay as you go. The more you use it, you will have to pay accordingly. So you get monthly bills, right? If you use 5 servers, you pay only for the 5 servers. If you use 5 servers for 5 hours and rest 19 hours only to 2 servers, you'll pay accordingly. Pay as you go. That's the model of the pricing model. We'll understand the cloud pricing model. That we need to understand about it. So that's how the definition, on-premise and cloud, right? Are we good with the definition, right? So that's how we should take it. Okay, it's nothing on the cloud. People think what it is, right? So now awareness is coming, but earlier when I started, right, some 5-6 years back, people used to wonder, what is this cloud? Right? And nothing, it's same thing, right? That's how we need to see things, right? And why do we use cloud? Again, the same concept, right? We don't have too much of amount of money, right, to invest to set up our own data center. If I have a business idea earlier, there was no other option. I have to set up a data center. Amazon.com, Jeff Bezos had this idea of this application, Amazon.com retail application. He had no other option but to set up his own data center and bring the application up and running. But today, it's not like that. If you have a business idea, you can leverage the servers in the cloud. That's how the companies are doing. The small scale companies or the startups, that's how they're doing it. They're leveraging the cloud, getting the infrastructure up and running. Dropbox, if you use, they're using AWS. Netflix, right? You must be using, everyone is very aware of Netflix. They use AWS. So a lot of use case. So think from a cost perspective, very important, right? If I just talk about it, why do you use cloud, right? Why cloud computing? So obviously efficiency, cost reduction, no doubt about it. Right? That's one of the important aspects. Scalability. Yes, today if you need 5 servers, you will pay for only for 5 servers. If tomorrow you need your business, let's say you started your business, you started your website application in the cloud, you started with few applications, few servers. Because the user load was not much, you started with few servers. Now your business is growing. You don't have to worry. With a click of a button, click of an option, you will be able to scale up your servers. That's how it is. Right? Scalability is not a problem. Disaster recovery. People, those who have their on-premise system as well, they are going to cloud for the DR because they have to do the disaster recovery, backups of your data so that in case of disaster, they can recover. Security, data is secure. Cloud service provider a lot of services to keep the data secure. Encryption, data at rest, data in transit, encryption. They have key management services, KMS. The customer can also set their keys for the authentication, for the encryption. There are a lot of services. They have firewall, they have sealed. There are a lot of services to keep the data secure. So many advantages of cloud. That is why there's a need, because every company is using cloud. So we should know cloud. That's how it is. Because if we do not know how it is deployed, how are we going to do anything, right? We need to understand what all services they have used, because when you use cloud, you use basically services. When AWS was launched, they launched with 3 services only. They launched with only 3 services. Trust me. Way back in 2007, only 3 services. You know what are those 3 services when AWS was launched in 2007? That was EC2, because the use case, right? The use case of cloud doesn't change. Servers, everyone wants to use cloud because they want to get the servers. That's how they will deploy the application, their web server, app server, database server. So EC2, Elastic Compute Cloud, stands for Elastic Compute Cloud, EC2. First service was this. S3 was the second service. Simple storage service, S3. For the storage, guys, again, the use case, if you want to learn cloud, guys, understand the use case. Then you will understand, okay, it's same all across. I see it is same in AWS, Azure, GCP, because I look at the use case. What is the use case of using cloud? Why people use cloud? They want to get the servers. In AWS, they will use EC2. In Azure, they call it something else, virtual machine. In GCP, they call it compute engine. Works the same way. You need the servers. You need the storage. You need the databases. Like the use case, if you pick up the use case, it will become very simple. So S3 is the simplest storage service. The entire Netflix content is stored in S3. Entire Netflix content. And there no doubt Amazon Prime videos where they would be storing the content. The entire Netflix content is stored in S3. So when you're watching S3, you're getting the content delivered from S3. And the last service was SQS, simple queue service. This is for the developer. When they write the code, all the messages to be in the queue, so SQS, simple queue service. So these 3 services was launched in 2007 when AWS was launched. You know how many services they have now? 200 plus services. And it is growing. It is growing. The more the advanced the technology would grow, it will keep on growing. Now OpenAI has come ChatGPT. Now they will try to integrate ChatGPT in all the services. That's going to be the future, which I see. It's already automated. Cloud is all about automation. Cloud is all about automation. Just think of a use case. I am somewhere else located. I am in India, in one city, I'm here. But I can create server in any place of the world. Wherever they have the data center, AWS has that data center, they have given me an option that I can select a region wherever they have the presence. I can select Ohio in US East, in US West, in Europe, in Paris, in Sydney. I can create servers there. Being here at the same place, I can create server. Cloud is all about automation. They have automated it. Now ChatGPT, OpenAI, ChatGPT has come. Now they're going to further automate it. We need to get onboarded here. If people are not knowing cloud, they're going to be left far behind. That's the future, because cloud has automated everything. Earlier we used to have, right? You guys are performance engineers, so you will understand. Earlier we used to have these roles of DBAs, network engineers. Now those roles you don't see in the market now. They have taken up by all this automation which has been done in the cloud. Now all the network engineers, they are learning VPC, the cloud, networking in the cloud. Because they don't need to now go to the data center and work, because it has already been taken care. Now they need to use this console for the networking. Earlier, network engineers was to go to the data center and set up things. But now everything is done by the cloud service provider. They need to learn here, right? Automation is at its peak in the cloud. I can create the servers, not just the servers. I can deploy application. I can set up load balancing. I can have anything up and running, just being remotely located. I can create servers anywhere. I can create application anywhere in the world, and I can have the website up and running. I don't need to be physically to any location to set up a data center in Sydney. No, I don't need to be in Sydney. Cloud means automation. Cloud is the perfect example of automation. If you know about EC2, I'll talk about that EC2, right? EC2 is the service where we use this service to get the server, right? If you have a server requirement, you go to EC2 and create some server. You can configure what operating system you need. I can right now selected Mumbai here, but I can select Ohio. If I want to set up a server in Ohio data center, trust me, Ohio data center, yes. I just need to select this, and I can click on instances, create launch instance. I'm going to launch a server right now in Ohio. In one of the data centers, I'm going to do it. Not just that, I can configure which operating system I want. Mac, Ubuntu, Microsoft, Red Hat. What should be the server capacity? 1 vCPU, 4 vCPU, 8 vCPU? I can configure that. I can configure all the security aspects, key pair, firewall. I can set up everything remotely. Once I get the server, I will log into the server. I can install whatever I need. Web server, app server, database server, whatever I need, because I got the server. I can set up load balancing, auto scaling group, everything. I can set it up. So that is what we need to understand, that we need to know cloud, because every company is using cloud, and we need to know the best practices, what all services, 200 plus services. Look at this, just click on the services here. For every use case, now you have a service. I talked about compute. They have EC2. But EC2 also, the compute also, you have so many things. Lambda has come. Lambda. Right? I hope some of you or many of you would be knowing Alexa device in your home. Have you seen Alexa do this, do that? Have you done that? Anyone? Alexa? That Amazon, in the Amazon website or so many websites you get this. That is based on Lambda technology. That is based on Lambda. When Alexa is idle, it is not consuming any resource. The moment you say Alexa, it gets invoked. And when you ask something to do, it uses the compute power of Lambda, it uses the cores and the RAM, it converts your human language to machine language, it processes the machine language code, then it reverts you back, converting your machine language to human readable using Lambda service. This is a Lambda service they use based on this. We have Beanstalk. Beanstalk we use if you have a code, just any code, Python code, Java code, any code you have, you don't need to do anything. Just upload the code, your application is up and running. That's how automated it is. Trust me. If create application, I will do create application. I will just click on create application. I will give a name. I will select a platform. Let's see if I have a Java code. I want to run a Tomcat server. That's all. I will select a Tomcat, or if I have PHP code, Python code, I will select this particular runtime. I will simply upload my code. That's all. Upload your code. I'll just browse local file. I will just go somewhere. I'll just try to figure this out somewhere. I'll just go this, and I'll just Beanstalk. I have a code. I will simply node this application. I will deploy this code. My application will be up and running. In 10 minutes, I will get a URL and my application will be up and running. Not just any code, but Tomcat, Java, Docker, any code. That's the level of automation we are talking about here. Just you have code, deploy the code. Beanstalk. You have got so for every use case. Databases. Earlier, if you have dealt with database, we used to get a server and install a database, do some tuning. First of all, installation is a big headache. Give me the steps. Depending on databases, Oracle, MySQL, Postgre, what is the configuration parameters? Give me that. Give me all the commands. It's not able to install. We are struggling to install things. All these hassles have gone away. Use managed database. Just go to your RDS, relational database. We don't just have relational database. You have non-relational database as well. Document DB, like a Mongo database. You have so many databases. Time stream, like you use Influx, right? So they use time stream. Influx is also a time database, time series database. Use this Amazon time stream. So let me show you an example of RDS, relational database. Just go to RDS, select the database of your choice. Could be Oracle, MySQL, MariaDB, Microsoft SQL Server, Postgres, could be anything. Select that. Just select you give the machine type where you want to install and those things. Just do that. Click on create a database. Done. It's going to be bootstrapped within 10 minutes. Your database is ready. Just select the Oracle or whatever database you need. Select the version. Let's say I want to select Oracle or Microsoft SQL Server. Select high availability will be taken care. If you select this production, high availability will be taken care. High availability. Use default for high availability and fast consistent performance. Give the database name, give the credentials, password, give the machine type you want to install database in. Just give auto scaling, database storage auto scaling. Do you want to enable it? Your database will never run out of disk if you click this option. Done. You want to create multiple AG? Yes, because for high availability, I will deploy that in the two data centers, multiple AGs. That's all. I will just come here and create database. 10 minutes, my database is ready. Ready. I can go to the database, insert the records. Done. Earlier, we used to have DBAs. Now, only job is to tune the SQL. Once you know the cloud, that SQL tuning is a skill. Whatever the query you are writing, SQL query, you have to tune that. Indexing, right? Taking less time, you need to tune the SQL tuning. Only skill is required is that. That maintenance part, big things, gone. Logs, checking logs, everything would be in the UI. Once database is ready, everything is in the UI. I'm taking one of the last batch. I'm taking one of the classes is Saturday. Okay, I can invite everyone here. The database course I have, that database topic is about to come. One of the February batches. This Saturday I'm taking this class. I can ask them to invite you. Anyway, if you are getting enrolled, I'll talk about that. So that's how the not just the RDS relational, but the NoSQL database also. We have used every use case in the cloud. Game development here, machine learning, use these services. They have automated everything. The time is coming. Trust me, with this chat GPT, I believe the time is coming. Your skill set is gonna be, you're gonna be very, you'll be knowing a lot of things. You are required to know a lot of things. Even I everyone IT, that's the rule, right? We all have to grow up. We all have to learn and grow in IT if you want to survive the IT, because of the technology getting involved. Because now the things are coming, everything is going to integrated with all those new technology. Will now that every cloud service provider will be thinking around that. Okay, so they have automated this. Now, if you just go to ChatGPT, write this code, they'll give you the full code itself. Then why they will hire a fresher? They will, why they would. So think about that, right? So it's having impact. So you need to know. Everyone needs to know. When I need to know a lot of things here. Everything need to know, and they will use Open ChatGPT. They will integrate that with a lot of services. We need to know even how to use that in the future. So it's never gonna be, cloud is going to be the future. In any day, even if 10 years, 15 years, cloud will be there, because we cannot set up a data center. That's a fact. Not every company can set up a data center. That's a fact. Everyone has to learn, and this will grow. Even this cloud automation is already there, but this automation will go to the next level now. That's my prediction. Next level now. Further automation will happen. A same person would be required to know a lot of things. Same person would be required to learn a lot of things. You would need to know a lot of things. That's how it's going to be, because everything is going to be automated. That's how we can survive, right? Okay, so I'm talking about cloud. I got carried away, guys. So yeah, so for everything, right? For robotics, for security, for storage, for every use case, you have the services now, and it's growing. They started with 3, now they have 200 plus. Automation is already there. Now they further automate things. So we need to know cloud. So we will be starting with the cloud, right? The first thing as part of the course, as I highlighted, right? Will be Linux. It's going to be very important, because I cannot stress this. This is too important. Okay, I know that right now, if I ask everyone simple question, okay, I'll ask simple question. There's a log file, error log file, application log file. There is some text is coming. I want you to filter or select when that error message coming, 10 lines, top 10 lines above that error message, 10 lines below the error message. So can you write the code right now? That's important. That's important, because you don't want to go over 1,000 lines, right? Wherever that error is coming, error message is coming, I want to see the stack. What is the process, why error message has come, and what has come after that. So we need to know what the bottom line is, what I'm trying to make. We need to be comfortable with Linux. We need to know basics of Linux, shell scripting, automation. Very important. That's why this particular topic, right? And already I talked about the Docker. We are already in the microservices. Kubernetes again. So Docker and Kubernetes is going to be the future. It's still the future, because we are in the microservices world. All the development is happening in the microservices nowadays. Even the monolithic applications are being divided into microservices. That's the thing. The monolithic applications are divided into microservices. What is monolithic applications? Can anyone help me understand what is monolithic applications? What is microservices? Anybody? Feel free, guys. Anybody? I'll definitely add after that. I just want to know. Get started. Can somebody get started with the definition? If you know, I would have explained that.
Everything bundled in as a single unit.
What? Can you come again? Praveen?
Everything is bundled as a single unit, like a web layer, app layer, DB layer, or middleware as a single unit itself.
Okay, no. So
While in
let's
case
focus
of
on the app layer
microservices,
itself. Focus on the app layer itself. All the business code. So let's say you have a three-tier
yeah,
application, right? Let's say you have a three-tier application.
yeah,
You have web server. Let's say, imagine you have web server. You have, let's say, app server. Let's say you have database server. Let's just imagine that you have these three things. So focus on the app server, okay? So when you write the code, right, logic. So basically in one application, there are many modules. There are many modules. Let's say payment module, inventory module, right? Or some other module, right? So a lot of modules we have, and that all the modules make my application, right? When, let's say I'm going to draw the modules. Let's say I've got multiple modules. I have this module one, I have got this module two, when I have this module three, I've got multiple modules. When and in these all these modules, what you do, you write the functions. That's what you do. You write the code. You write the code. You write, let's say you have written code here. Let's say you have written code F1 to F20. Let's imagine. I'm just giving a number. Let's say you have written the code F1, F2, and so on to you have written the F20. Some 20 code. Let's say you have written 20 code here, 30 code here, 50 code here. When you call the functions anywhere and everywhere across all the modules, across all M1, M2, M3, when all these modules are deployed together as a single unit, when all these modules are deployed as a single unit, right? Because when I say deployed as a single unit, basically you are calling the functions across these modules. Okay, that's what I mean. Let me bring the pointer. Okay, give me a second. I'm bringing my pointer. Yeah, here we go. So let's say I'm calling. Let's say I have this. I have this M1. I have this M2. I have this M3. Okay, and let's say I've written this F21 to F50 here, and I've written F51 to F100 here. Let's say I've written the functions, and there is a huge dependency across these modules M1, M2, M3. If F2 is being called, like all the functions are being called anywhere and everywhere. There's a huge dependency. And basically, when you, let's say you're writing all these functions in Java, let's say, so you deploy as a one unit, and when you build it, you get one jar file. Where in this jar file, all the methods will be there. So this is called monolithic applications. The problem with this kind of application, that issue with one of the even issue with one of the functions, the issue with even one of the functions, even issue with one of the functions can bring the entire application down. Monolithic applications. That's not the problem. So the best way is to separate them, make them microservices, so that at least we don't call the functions directly. If M1 needs to, the idea is, what is the solution for that? Solution is to make them independent. Make the modules independent. Basically, what I'm telling about is this. Make these modules independent. Make it independent. Don't call them separately. Make it as a separate entity. Separate entity. One microservice can be written in Java. Other microservices, since I'm not calling the functions, there's no dependency. There's no dependency. All are separate, segregated. I'm not calling the functions. I'm deploying them separately. I'm getting different jar files. Let's see if I'm writing all the modules in Java language, Java technology. I'm getting different jar file to deploy. I'm not calling the functions. Since I'm not calling the functions, I can develop M1 in one technology. Let's say I can develop M1 in Java. I can develop M2 in Python because I'm not calling the functions. I can develop M3 in Go, depending whatever suits well for my requirement. And if M1 needs some information from M2, I will expose the RESTful endpoint. I will expose some API, some get calls, post call. I will expose some RESTful endpoint, and that's how it will be. That's how even Make My Trip makes calls to your AirAsia, your Indigo Airlines. They expose the API. If you want to book the ticket, the Make My Trip will call the API, and that's how things gets done. API calls. So that's how the communication happens. And we are in this world, microservices world. All the latest applications that you see, Swiggy, Uber, all these things, applications are being developed in microservices architecture. If one functionality, the advantages, guys, if M1 has some issues, it's not going to impact the core functionality of M2 and M3. Core functionality will not get impacted. You get high availability in the architecture itself. It's not like if F2 is not working, because so dependency is there, so much dependency is there, entire application can go down. It's not the case here like this. It's not the case like this. I can scale separately. Let's say if for this monthly application, right? Let's say you have been performance testing. Let's say that you are running a load test and you found that one of the transaction is taking high response time, and when you observed, you saw that CPU is the contention. So can you scale up only one transaction? Is it possible here? Scale up the CPU for only one transaction? Is it possible? In the case of multi applications, no. You have to scale up the entire application server itself to one transaction. But here, since I'm deploying the microservices separately in different machines, I can scale up only for this module. I can scale up independently. That's why we will learn about containers. We deploy microservices on the containers, and we use Docker to create containers. And when we have a lot of containers, we use Kubernetes to orchestrate them. The Kubernetes is going to be the future. It is still right now. If you are not onboarded, you are far behind. Trust me, take my word. Kubernetes is going to be the standard. The standard. Kubernetes from Google. Back in 2015, not a while ago, okay, so 7-8 years back I'm talking about. Docker Inc. is the company. They have this technology called containerization. Google was listening to it, and they talked about that you have the microservices, you can deploy the microservices on the containers in the one VM, you can create multiple containers and blah blah. A lot of advantages. Good technology, no doubt about it. Google was listening to it. Google told, I am using this technology from last 1 decade. Google was using this technology from last 1 decade. So who scales better than Google, guys? Who handles load, traffic, volume of requests better than Google? Do you know anyone? No. Google is the most, because of the Kubernetes. It scales so well, Kubernetes. It has, if you use Kubernetes, half of the performance issues will go away just like that, just by adopting Kubernetes. Only thing on the performance, the scalability issue, need not worry. Self-healing, you did not worry. Only thing you need to talk about the application code performance improvement. You need to improve the application code. That is what you need to do. After that, rest all scalability issues, all the things will be taken care by Kubernetes. Kubernetes is going to be the standard. And that's where we need to learn Kubernetes, and that's why I have incorporated this course. The wherever I work, it's all about Kubernetes. Nothing is deployed on a VM. all our microservice architecture. That's how it is. So you should try to switch to an environment where they deal with cloud, they deal with microservices, they deal with Kubernetes. You need to do this, okay, at the earliest in your career, because that's how the world is progressing, and that's how you can keep up with the pace, right? And that's how this course is designed to help you with that, right? DevOps part, we all understand why DevOps. It's all about automation. We talking about Terraform, Ansible. Why Terraform? Why we use Terraform? Why we use Terraform in production? Let me ask you this question. Okay, we have 12 people here in this group, including me. 12 people, right? So, guys, I'm going to ask you this question: how many servers you have in production right now? Wherever you work, how many servers you know is there in production? Just if you can give me a rough also, right? So that's fine. Just I want to understand the scale of application that you're working. You may not be involved in production, but obviously performance testing you'll be doing, right? Mostly you'll be doing about performance production thing, right? How many servers are deployed in production? Okay, so nobody responding, so maybe not clear. So let's say I'm going to give you one example. Let's say Axis Bank or ICICI Bank or Flipkart. How many servers do you think they would have, looking at the scale of application they support? Many, right? Many thousands. Yes? Would you agree with me on this, everyone? 1,000 is also a less number, right? If you look at the Hotstar, they support up to so many millions users support, right? So many millions. So they need servers. So I'm going to ask you this question, and I want everyone to answer. When you have 1,000 servers, do you think somebody is provisioning those 1,000 servers manually? Do you think the applications that you're deploying on those 1,000 servers are done manually? All the configurations that is being done on those 1,000 servers are being done manually? Do you think so?
No.
It cannot happen manually. It is just not possible with the scale of server. If you're talking about 5, 6 servers, then fine, you can do it. So that's why we need these automation tools, or Terraform, Ansible. We need these tools in CI/CD automated fashion. When I'm deploying a code, the code should get replicated all across. We need auto scaling. One of the important aspects of a load performance engineer is the auto scaling. Here in the Kubernetes also, horizontal cluster auto scaler, you need containers to auto scale. Based on more users come in, automatically the containers would auto scale or scale down. Nodes should scale up and scale down. Auto scaling of the nodes. Elastic load balancing and auto scaling. We all need to know all of this as a performance engineer. And that's why this course. Right. Okay. We need to understand these words. What do you mean by disaster recovery? DR. DR is one of the important thing, right? As a customer, I don't want downtime, right? If I have some application deployed, mission critical application, a lot of users are using it. If I am Flipkart.com, let's say, imagine, I don't want my application to go down. Or I'm an application of that scale where so many people are accessing, putting orders. I need to be secure. I'm also thinking to add security module, okay? More and more security module to this topic that will be added up in the future. Well, because production is all about security also. I'm yet to add security, but I'll add up slowly, yeah. So think about that, right? I don't want application to go down. So how it is possible? So we need to leverage the cloud, no doubt about it. The cloud has got regions. So I need to deploy my application in multiple regions. If I talk about the cloud, right? So region, let's say I talk about Ohio region. So one region has got multiple AZs, availability zones, data center. So in one region itself, Ohio, let's example, I have got multiple AZs, AZ1, AZ2, AZ3. I have got multiple AZs, data centers, right? And I don't want to go down. I can ready to spend some amount, but I don't want to go down. So what is the approach? So I should not have a single point of failure. Understand this. So thought process. I should not have a single point of failure. So for every component I have, I'm definitely going to have the multiple nodes. But I don't want to have I need to have redundancy in place. Redundancy has to be there. If I want to be highly available, so multiple node per AZ, multiple node per availability zone is the approach. Then I go with multi-AZ deployment, because there could be a chance flood can come, natural calamity can happen, one AZ can go down. So I need to definitely have two AZs. That's why even AWS recommends. AWS in the infrastructure itself, they have got multiple AZs in one region. In Ohio region also, they have got multiple AZs for the same HA region. So I'm going to deploy multiple nodes per AZ, multi-AZ deployment. That's about one region. What if this region goes down? Entire AZs. Very less likely. Very less likely. Not likely. But what if? So I need to have the setup. Let's say this Ohio, I can have in the US East also, or US West, or in Australia, in other region. I can have application up and running. So I can decide now, do I want active, both the regions to be active, or I want active passive, because more the servers I will have, the cost will increase. So that's about the disaster recovery we talk about. DR setup, active, what are the different steps for keeping you highly available? See, in production, that is what important. See, performance is all good, okay? Performance is all good. I'm not denying that. Security, even important than performance. Security. That's why we have security engineers, cloud security engineers, very popular skill set. But these things are very important from a production point of view. And that's what we need to understand being an SRE. You need to start thinking from production point of view, from the customer end. What the customer end? Customer end wants everything: HA, high availability, performance, security, cost, less cost also. Cost optimization should be also there. Reliability, even if the application is going down, one of the servers going down, I'm not losing the performance, fault tolerance. Reliability, system should come back. Fault tolerance, I'm not losing the performance even if some servers are going down. Chaos testing we have to do in production. See, we need to think from a production point of view, being an SRE engineer, right? So that is the mindset I'm trying to tell you. That's the different mindset. Performance would be one of the things in your plate. When you think from these angles, performance is one of the things in your plate. And that you can do performance testing, right? And you can analyze things, but you have other things to also look into. Automation. So that's why SR is a very vast domain. Okay, it's a very vast domain, and that is why it's so important. So much they are so much valued, right? Yeah, and that's why we have so many things in our course, right? So that's the thought process, guys. Okay, so that's all I wanted to cover, guys, today. Okay, yeah. Okay, able to follow, guys. Able to sync up with me, you guys. What I'm trying to tell you. Yeah.
Yeah, that's perfect. Yeah. Roshan.
Yeah. Good. Perfect, guys. So we will not meet tomorrow, okay? We will start our batch. So we will close our demo sessions today, okay? We'll be done. Okay. We'll start our batch from next Monday. Week it will be weekdays, okay? Uh, I can ask those who are getting, so for them, like for the people who will be confirming the enrollments, we'll create a separate WhatsApp group for them, and I'll be also inviting you. Once the separate batch is confirmed, separate group is confirmed, I'll be also inviting to the my courses, like the other batches that are going on. Right? So I can just help you get some perspective. I can just anyway. I'll be teaching everything in your course, but I can also invite you to my other batches which is going on, about to complete. That Feb batch is about to complete this weekend. I can invite you there as well. Okay, so I can send an invite to the private WhatsApp group. Okay, so that would be the plan. We are not going to meet tomorrow. We're going to meet Monday, our finalized batch. Okay, and I'll be sending you the invite for the. I'm taking up. Okay, I'm taking. Let me tell you. I'm taking up this database topic. Okay, um, cloud database performance. I'm taking up this topic. Okay, where is that? Let me show you. Okay, what I'll be taking up to them. I'll be taking up databases, AWS databases. I'll be taking up this. So I'll be taking up databases services. What is, how do you, from the performance point of view, from the architecture point of view, right? I'll be taking up that different databases that we have in AWS, and we'll talk about multi-AZ deployment. How can you make sure your database could be highly available, right? I'll talk about read replicas. What is the read replicas from the performance point of view? Very important, right? I'll be sharing some links. Okay, so that's what I'll be taking up. Okay, so I'll be inviting you, folks. Okay, fine.
So Roshan,
Yes, go ahead.
one question.
Yeah, go ahead.
So all these sessions will be practical sessions, or we just talk about the theory piece
No theory
during the.
at all. No theory. I don't. It's both. It theory. See, everything would be hands-on. Everything would be
Yeah.
hands-on. See, today is the demo session, right? I have to talk about
Yeah.
what we are planning, how we are planning, right? But once we
Mhm.
start, I'll be showing everything in the cloud console, right? That's why I started. Everything, whatever I was talking about, right? Everything I'll be showing you. Kubernetes.
Mhm.
I'll be creating cluster. I'll be using EKS cluster. EKS is a
So we will create a cluster in the real time, right?
real time. We will deploy our application, microservices. Yes.
Mhm.
We will set up our own Prometheus Grafana. Everything, whatever is there, hands on. I'll be showing you. I will not let you do the same time because we may not have time, 1 hour, right? So I cannot let you do same time. But I'll be showing you hands on.
Okay, okay, okay.
System will be recorded and you'll be given the recording, right? As I showed you other day, right?
Yeah.
Roshan, since we are using AWS here, right, for
Yeah,
this
yes.
course,
Yeah. Correct,
Roshan,
correct.
are we
Yes,
using
yes. Yes, yes.
for that, like what kind of subscription we need in
Free
order
tier.
to do
You
all
will
these
not be
things?
billed anything, okay?
Free tier
Don't worry. You will not be billed any
free
amount.
tier is,
It will be
is free tier is sufficient for this?
what again? Come again?
Is free tier is sufficient for this to fulfill these things?
Okay, learning wise, yes, EKS is not free. Okay. Whatever I will take up, only the EKS is not free. I will be demonstrating EKS. See, if I show you my cloud bill, right? Let me show you. I have been using so many things, right? I can show you my bill. My bill is mostly around 200 to 300 per month. Okay, that's how it's gonna be. Even if you use it, I use it for the teaching purpose. My bill is hardly 200 or 300 if you look at my history of bills. Okay, that's how it's gonna be. $1, $2, $3. That's how it's gonna be. Okay, how much ever I use. So don't worry, you will not be billed. If you follow my instructions, you will not be billed. So Cloud Console has the billing, very good billing. They give you what you used, when you used, what day you used. They give you everything, and you can check the billing. I can go check the history. Just you can check the history, what all have been billed, right? So I can check for the last 6 months. If you show me March, okay. If I can view in cost explorer, I can show you my bill. Hardly it will be some recent reports. I can just go to history part. Yeah, so don't worry, okay, don't worry. All I can say, don't worry. I can select a range from January, let's say January to what date format it is. Anyway, okay, 4. Okay, look at this, my bill. That's how it is going to be. So in 4 months, I have billed only $6. So if you will be, don't worry, okay. So something, if you some amount here and there is fine, right?
Yeah, it's not a problem. And EKS, for EKS, there will be billing, but won't be like this. Not so much, right?
Yeah. I'm talking about 2-3 batches which I have taught. So yeah, you can think about that.
Yeah, thank you. Thank you.
Okay.
So, Roshan, does it mean whatever you showing hands-on in AWS, you will also be able to do with our free subscription, is it?
Yes. Only the EKS is the free. See, anything you can use it. Only thing you will get billed. If you don't pay it, they will suspend the account. That's what happened, right? So EKS only thing would be charged. Apart from that, see, there are a lot of free tier. If you just Google AWS free tier, they give you a lot of. See, even AWS wants you to learn AWS, because if the more people learn AWS, more people will use it, and that's how their business will grow. Even AWS wants you to learn AWS. So that's how if you look at the free tier, so many things are free. 750 hours of compute, S3 is 5 GB, RDS 750 hours. So yeah, so many things are free. DynamoDB 25 GB, Lambda 1 million requests you can make. There are so many things free. So yeah. Don't worry. I told you, don't worry on the cost part. If you follow my instruction, you will not get billed.
So is there any application like will be there like to do these kind of simulations?
Yeah. We'll be doing all the applications. Yeah.
I mean, like, is there any like readily available application to test like this?
See, think, okay, it is not Jmeter session where one application will be there. We'll be learning how to deploy microservices. It's not like a standalone application which is required here. We have to learn services. See, you need to understand what you are going to learn. You learn about services. I will explain you services first of all. In the cloud, what you can expect? You should expect that I will teach you all the services. You need to learn EC2. I will install EC2. I will install some application. I will show you how to install. I will show you S3, how do we work. VPC, I will show you. Route 53, I will show you different things. I will talk about Kubernetes. I will show you how you deploy Kubernetes. I will take one image. I will deploy that. So you don't need like one application you require. It's not a Jmeter where I will record it and I will replay it.
Okay, Roshan. Thank you.
Sure. Okay. Any questions, guys? Last questions. I hope you guys have the link. Right. Let me share the link again in case you don't have it handy. I will share in the group as well. I will ask my team to take these two links. We have merged these two courses. Okay. They have made it better. It will be much better in coming future. And I'm thinking to add security aspect to it also, because from production I'm working on security nowadays. Very challenging the performance. Performance has become minuscule now. Security has become major concern, because if you have security concerns, the company will sue you. So a lot of challenge on the security part. Yeah. So I'll be adding up what as a user what we should be knowing, right? So this course is gonna grow. Okay, gonna go because I am growing. I am learning. I am working in a very challenging environment. So this course is gonna grow, and I'll keep you updated. Okay, that's how it is. Okay, guys.
So
Yeah,
one concern is here.
go
This
ahead.
site reliability and the cloud performance is the different courses.
No, both are same. I have clubbed it. Earlier, I planned to make it separate, but we have clubbed it. So just give. Just
Means in that course there is a both site reliability engineering also and cloud performance. Both are in that course.
yeah. Both are there. Both are there. I have clubbed both the
Okay.
things. I have made it better. SRE course has everything of Cloud P. Cloud P doesn't have everything.
Okay. Okay. Means site reliability is also included cloud performance and other things also.
Other things, automation. Yes.
Okay.
Sounds good?
Yes. Thank you.
Perfect. So thank you, everyone. We will meet. Hopefully, we'll meet this Saturday and coming Monday. Thank you so much, everyone.